Now we are going to start with three-dimensional plotting. Now MATLAB offers a variety of three-dimensional plotting commands. First is three-dimensional line plot. The plot3 function is similar to plot function except that it accepts data in 3 dimensions. Instead of just providing x and y vectors, you must also provide a z vector. So these ordered triples are then plotted in 3 space and connected with straight line. Let us take an example. X equals to line space from 0 to 10 pi with a step size of 1000. Y equals to cos of x and z equals to sine of x. Now I have to draw a three-dimensional plot, so I am using the plot3 command between x, y and z. So this is how the three-dimensional line plot is displayed. There is one more command which is comet3. This command actually generates an animated version of plot3. So this is how the comet3 function works. So for two-dimensional, we are just simply using the comet function, but for three-dimensional plotting, we are using the comet3 function to draw the or to generate an animated version of plot command. So next is surface plots. The surface plots allow us to represent data as a surface. We will be experimenting with two types of surface plots, mesh plots and surf plots. The first is mesh plot. So there are several ways to use mesh plots. They can be used to good effect with the single two-dimensional M cross N matrix. In this application, the value in the matrix represents the z value in the plot. The x and y values are based on the matrix dimensions. Let us take an example. Like x. First of all, I will clear the command window and take the example as x line space 1 to 50 with a step size of 10. Y equals to line space 500 to 1000 with the step size of 3, and z equals to 1 2 3 4 5 6 7 8 9 10 2 4 6 8 10 12 14 16 18 20, and our third row is 3 4 5 6 8 9 10 11 and 12. So this is vector z. The x vector must have the same number of elements as the number of columns in the z vector, and y vector must have the same number of elements as the number of rows in the z vector. Now I am going to use the command mesh x, y, z. So this creates the plot as shown in the figure. Now notice that the x-axis varies from 0 to 50 with data plotted from 1 to 50. Compare this scaling with that now, which we will plot in the surf plot. So for surf, we are using the command surf x, y, z. So surf plots are similar to mesh plots, but this creates a three-dimensional colored surface instead of a mesh. The colors vary with the value of the vectors. Now, we can use the shading scheme for surface plots, which is controlled with the shading command. The default is faceted. Interpolated shading can create intersecting effects. We can use command shading interp. This will provide the interpolated shading. We can also use flat shading by using shading flat command. So this is how the flat shading is used. The color scheme used in surface plots can be controlled with the color map function. Color map, I just want to represent the grayscale graph, so I'm just writing the gray in the parenthesis. So now my graph is shown like this. There are various other options for color maps. You can go through all those options by writing help color map in the command window. This will show you all the other options for changing or controlling the color scheme of the surface plots. Now next is contour plots. I'm going to use same x, y and z values. So I'm using the same x, y and z values. Now I'm going to plot the contour map. By using contour command. Contour plots are two-dimensional representation of three-dimensional surfaces, much like the familiar contour maps used by many hikers. So this is how contour map is shown. We can also use a surf C command to create a plot with a combination of surface and contour plots. So here I'm going to draw the surf C plot. In my second window. So this is the surf C plot. Next is pseudo color plots. Now, pseudo color plots are similar to contour plots, except that instead of lines outlining a specific contour, a two-dimensional shaded map is generated over a grid. So MATLAB includes a sample function which is called peaks that generates x, y and z matrices of an intersecting surface that looks like a mountain range. Like I'm going to write here x, y and z equals to peaks. It's peaks. I have written this double S. So peaks. So now I'm going to write the code for pseudo color plot. So in first window I'm using p color command. This will returns the pseudo color plot. second window, our second subplot is P color subplot, but with shading interp. So the grid is deleted when interpolated shading is used. You can also add contours to the image by overlaying a contour plot. So in subplot 2, 2, 3, I'm going to overlay a contour plot. Hold on, then contour. X, Y, Z, 20 with black line. K. So the number 20 here specifies that 20 contour lines are drawn, and K indicates that the lines should be black. If we hadn't specified black lines, they would have been the same color as the pseudo color plot and would have disappeared into the image. Now finally, a simple contour plot was added to the figure for comparison. So our fourth figure is for simple contour plot. So this is how different plots are displayed by using different commands. So additional options for using all the three-dimensional plotting functions are included in the help window. So you can go through all the options by writing help 3D plots, and you can go through all those options by yourself. Thanks.